Right. So we were discussing on the Ethernet type 2 frames, which is having the structure like this. So based on that information, let's further analyze the similar capture or packet by using this, whether it is within the guidelines or the structure. So basically, the first, you can see the first section, which is identified as frames on the details of number of bytes in the packets and the bits on the wire, which means it should be the bytes to bits conversion mentioned there, and the number of bytes captured showing in the particular frame. Then if you expand on the Ethernet segment or Ethernet to details, that's you can see the details on that. Source identified with the MAC address, so the mapping identification there, and the destination with the naming conventions with the MAC address there. So source and destination MAC addresses are there as we expected on the Ethernet 2 frames. So then if you go into the details of the destination, you can see the exact MAC address with the hexadecimal three of the 6 places or the 3 states, and you can see the details on the something called the source address as well, similar to the saying the MAC address. So these are the concern fields which we are verifying against the Ethernet type 2 frame structure. And you can see the type is defined as IP, which is 0800 or 0800. The frame check sequence there in the packet. So these are all these covered in the area of the Ethernet frame 2 required all these fields to be included based on its structure. The first 3 ones, source, destination, source, and the type are included there, and the frame check sequence for the verification of packet integrity. So you can see that. The Ethernet 2 frame details. And then we will be expanding on the Internet protocol, which is the layer version 4, which is the plane here. So if we expand Internet protocol version 4, this is having more details than Ethernet 2 frame type. So you can see all the details here. The differentiated diffserv information on this as the first hand. You can see the Internet Protocol version 4 is highlighted. If you captured IPv6 packet, then you can see the version number 6 here. The header length identified as well with 20 bytes. And the differential services field, which is usually for the quality of service implementations. When you are prioritizing traffic, we are implementing something called quality of service, and we are marking the packets, the prioritize or packets at the edge, which means closer to the, let's say, closer to the servers or the computers at the switch level, the access switch level, where we can mark, then classify according to the classes of traffic. Like if you are certain applications seem to be having higher priority or the low latency requirements or the kind of a thing, the critical application or the real-time application, based on the category, you can classify the traffic after the marking. The traffic you can classify. Then you can implement QoS policies or based on the marking and classification at the edge, and you can implement policies on the bandwidth the bandwidth hungry areas, like let's say that you don't have sufficient bandwidth. If you are if you are not running the full capacity, then probably you need to filter the traffic or classify the traffic and give the priority for based on your QoS policy. That is called QoS implementation. So that particular implementation required this marking. If you are marking your applications at the layer 3 or the IP layer, you need this diffserv bits to be configured, which is identified as DSCP bits. For the classification, marking and classification, you need to follow DSCP bits. If you are doing layer 3 QoS, then DSCP, this is the field you need to concern on. Then this IP Internet Protocol layer, further having the details of total length of the packet based on this capture for the layer 3. And identification, you can see this total length of the packet minus the Ethernet MAC address header. So because after the header removed when it is forwarding to the next layer, right? You should remove the Ethernet 2 header and upper layer information, and calculating and showing only as 660 for this particular this thing only. You can see that frame at the frame level, it's showing only showing 674 bytes, right? You can see it here. And when it is at the Internet Protocol version 4 IP layer, your total length is identified as 660, which means 14 bytes utilized for the Ethernet 2 or the frame layer, which is the previous diagram. You can see that MAC header usually taking 14 bytes. Those 14 bytes are included at the frame level or Ethernet 2 level. But Internet Protocol level or layer 3, you are only having those 14 bytes removed, and now it's identified as 660 byte, including the Internet Protocol header. And the identification, there is an identification. This is an incrementing number. You can see the packet identification at the layer 3 IP layer. This is the number. It is on the hexadecimal, and the flags there. So this the particular case, you can see the flag don't fragment. The don't fragment means if you are getting a message with a large, it's required to communicate more than one packet, which is the packet size defined previously the 1518 bytes, right? You need, if you have a message with 2000 bytes, you need to send one packet with the maximum bytes you can include in this particular packet. The remaining bytes should send by using another packet, right? So that's a kind of a thing called fragmented. So if you received something larger in terms of the fragment, the identified as fragmented some bytes or some messages, you don't need to fragment because size itself less than 1500. So you don't need to set the fragment bit. So some of them are required fragmenting, then it is having a different different area of identification. So you can see that the flags here marked as do not fragment. Usually that's the best practice in terms of current day networking. So then you can see the flags. If there are fragmented packets, you can see the two other fields: the fragment offset, time to live, TTL, which we discussed on the multicast as well as the trace routes, and the upper layer protocol highlighted there. The TCP is the upper layer protocol. The analyzing via the internet protocol, which is on the layer 3, which is the network layer. The next layer is transport layer, having the TCP transmission control protocol. So that's the point with the flags implemented with the don't fragmented. You can see the fragment offset, the flag field identified. If it is identified, field is one, identified as one. There can be more fragmented packets following. So this is a kind of implementation. If you require more than one packet or more than the size of a packet, which is more than 1500, then usually it will be fragmented. Then again, in terms of TTL value, you know that the layer 3, if one layer 3 hop fast, then TTL value will be reduced by 1. Likewise, you can, usually we are using this TTL value for the multicast. If you need to restrict multicast reach, we discussed on this idea on the multicast, IP multicast security. You can set up, let's say, for an example, if you configure TTL value by your application as now 3, it can only pass the 3 network segments, which are the 3 routers. So that can be put into this. If your application sending traffic with a TTL 3, then it's only reachable up to 3 network segments. So that can be defined here on the TTL segment time to leave. In this particular case, it configured up to by the 128 is the one for this particular packet. Then you can see this as a unicast packet. The multicast source is 192.168.1.116. So that is a private unicast IP address range. The destination is 162. That is not private range, but it is unicast. Is the destination. So you can see the source and destination to identify the protocol, upper layer protocol as TCP by expanding further. These are the informations you are getting in terms of the IP header, which is when you expand further in one packet on this particular area. All right, let's go into the details of further to compare in terms of different packets. So we were discussing on the Ethernet frame this particular case, and further on the layer 3, which is IP layer. And some of the packets like address resolution protocol, ARP is on layer 3, but it's having a different structure compared to the IP packet. So I mentioned here previously that ether type, if it is IP, you get 0800. If it is ARP, address resolution protocol, which is the protocol usually you are mapping MAC addresses to IP. So we discussed this. So it's the ether type is 0806, right? We have been discussing this IP packet, but now we are on the OSI layer 3. That's again IP packet is layer 3, but ARP is also layer 3. So this is the structure of layer 3 packet. You can see the ARP as the identification field here, the type of Ethernet 2 frame, and it is the layer 3 identifies as an address resolution protocol. The previous one identified as Internet Protocol version 4. You can see that. So in this case, still seeing the MAC address, sender MAC address, IP address, target MAC address, target IP address. You can see all this is related to address resolution protocol to map IP address to maintain MAC address to IP address combination. Ethernet frame destination. You can see the Ethernet frame destination here with all F, which means broadcast. So all the octants, 6 octant here, having F, that means broadcast. Previously we were discussing the layer 2 multicast with the activity example. Hope you can remember this particular packet I was this particular packet we noticed here that 239 255 255 250, which is a multicast IP address. It is having the MAC address of starting from 01005E. That is the range for the multicast thing. Usually what switchers doing is, if it's seeing this 01005E, it is just broadcasting to all the other ports other than the receive ports. And if it is receiving, that's the behavior, by default behavior for the switches based on the multicast MAC address identification. But again, for the broadcast, it's same. Broadcast all having F, and the switches usually flooding on the broadcast and the multicast. After we implement IGMP snooping, the multicast behavior changed, because only the subscribe or requested one getting the message, not flooding to all the ports as in the case of broadcast. But by default, it's multicast and broadcast behave at the layer 2 or the switch level. It's same. It's a flooding mechanism. If IGMP snooping implemented, then it's 01005E packets only sending to the subscribe one to the channel, but broadcast no filtering and send it to all the ports if it is having all F in the MAC address, destination MAC address. Okay. You can see that address resolution protocol usually works as a broadcaster, and to find out the MAC address of a particular machine to map IP address with the map. So this is the way it is doing. So destination is a broadcast, and you can see the source with the MAC address there. And there is a source IP address as well, which is the machine sending this broadcast. And then target is again, target MAC address is again related to broadcast and so you are getting response based on your broadcast. So it's included again in terms of this. You can map now the particular the target MAC address and the target IP address based on the response there. You see that Ethernet frame destination of the MAC address is broadcast, all having F. Type is ARP, which is having 0806. And the station has provided its own MAC and IP address in the ARP protocol sender fields. So then the one of the machine responding. So the responding machine having an IP address and the MAC address it's provided. Provide the IP address of the target device and puts all zeros in the target MAC address field. You can see the all zeros in the target MAC address field, but including the IP address. The target device should be return a similar ARP packet addressed to the requester with the MAC address in the sender field. So MAC address should be included as the sender field. So this is the main idea on the address resolution protocol, which is based on broadcast, but still layer 3 protocol, because you need to maintain IP address to MAC address. So just go through the details. DNS is used to sometimes used to resolve the names here with the MAC address to or IP address to URL mapping required for the DSC. ARP is usually using for the IP to MAC. DNS similarly using for the host names to IP addresses. Okay, layer 4. Now we were discussing on the Ethernet 2 frame and on the IP layer 3 with the IP addressing or the Internet protocol layer and address resolution protocol for the broadcasting. And the layer 4 is now user datagram protocol, which is UDP. You can see this particular case, the source and destination, the UDP header is only 8 bytes long. You can see the IP header length is 20 in this case, 20 bytes. Ethernet frame header is 14 bytes. You can see on the layer 4 UDP header, it's having only 8 bytes, most simple form of layer 4. And it's having a source application port, usually the transport layer having the application port ID and destination port, source port ID and destination port. In this case, all 4 zeros representing the all 4 twos representing the port source port, the destination port representing 24,260. And the length of it's showing that UDP header is only having 8 bytes long and consists of the following. So the UDP header mandating having these fields: source and destination port number. You can see the source and destination port here, and the length. This is the length of the UDP header plus the payload. You mentioned above that UDP header is only 8 byte and 8 byte plus 172, which is the payload. And you can see this particular length representing with a 2 bytes field, but totally this packet having 180, including the UDP header, which is 8 byte. And you can see the checksum for the authenticity, that this is the 2 byte, again, another 2 byte field used to check errors of the UDP header and data info checksum was generated by transmitter. This will be all zeros. So basically, you can see that 2 bytes went into the source port, destination port another 2 bytes, length again another 2 bytes, checksum another 2 bytes. All you require for the UDP to run 8 bytes as its header overhead. Right. So we were on now Ethernet frame and the IP packet and ARP packet and UDP datagram. So then that's about UDP. Now layer 4, we need to have the UDP having most simplest form. But the TCP having more complex number of fields. So TCP, the TCP header contains length can vary depending on options it may be used. And its simplest implementation, this is the simplest implementation. Usually it requires source port, source and destination port. The source port again taking 2 bytes. Destination port require another 2 bytes. So source port, destination port in this case HTTP, which is the port number 80. And you can see the sequence number. So sequence number take 4 bytes. This is the number that represents the first octet in any given segment. Sequence numbers are initiated at the beginning of new sessions as a random number, then incremented as data bytes and cents. When you are analyzing the packets, this sequence number is quite important to understand the flow. So basically troubleshooting requires to follow, you can filter out based on the sequence number based of a conversation, TCP conversation. Acknowledgement number. So usually TCP is a 3-way handshaking protocol. you should acknowledge once you receive the packet, you should send an action acknowledgement. So that's a reliable protocol compared to the UDP. UDP is usually one way and not required acknowledgement, but TCP required acknowledgement. So acknowledgement number required 4 bytes. When the acknowledgement flag bit is set, then the field contains next sequence number as expected from the sender, which in turn acknowledge receipt of the bytes received up to the point. So send receiver acknowledging it has received to the sender by using this acknowledgement mechanism, acknowledgement number identified here. So this is quite important in your troubleshooting. You can filter your packet capture based on the by adding a row for the acknowledgement bit. Then again, in terms of the flags, the TCP having several variants of flags, I included in our modeling discussion as well, network modeling. So TCP entire structure having different types of packets. In this case, pushback is the flag on this particular packet type. There are various types of packets. So it's beyond our discussion in this particular case, but I have been including a slide on the network modeling page with the entire TCP IP TCP operation. The flags field, it is having this the specific type of TCP packet, and it's taking 9 bits. These bits are used to control connection setups and termination and flow control mechanisms. All the flow control, as we discussed on the UDP, there is no flow control mechanisms. So usually, based on the speed, the TCP by default start with a slow start. If in certain cases we are tuning this for the low latency environment to avoid slow start. So it's depending, that is how usually flow control by using this particular flag bit. Then it's again another field required there is a window sizing. You are changing the window sizing based on initial communications or the process started for the TCP/IP. So it's taking another 2 bytes. The use of sequence and acknowledgement numbers are how TCP ensures the reliability and delivery of data by tracking the number node of receive bytes. That is why I mentioned you that these sequence and acknowledgement fields are quite useful in terms of the following the flow, troubleshooting the flow. Sequence and acknowledgement numbers are large and difficult for humans to follow. So Wireshark is quite useful there because it is difficult for us to process this flow down the flow because there can be random number assignments and all those things. So Wireshark was quite useful in there, can convert display these as relative values and start from 0 and all those the troubleshooting make easy based on the Wireshark sorting and display on these analysis stuff. So you can get several reports with this sorting rather than we follow up and write down on the papers or the write down on sequence numbers to analyze. Wireshark make our jobs easier for the troubleshooting, especially based on the sequence numbers and the acknowledgement numbers. And that's about in terms of different packets, so the frames, so the datagrams, structures. When you are troubleshooting, you need all these details, but we are not limiting. We discuss only few of the packet structures or the frame structures, but there are many other the frames and different types of the protocols they are addressing with the TCP/IP protocol suite. So you can see the 2 OSI layer model, DARPA, which means TCP/IP layer 4 layer modeling, 7 layer modeling, mapping to different protocols. This is quite important when you are doing troubleshooting in terms of uh, the packet captures. So you can see the data link and physical layer or network interface layer having Ethernet, which is we discussed on the Ethernet 2, and 802.11 are for the wireless LANs, and then the frame relay is a traditional protocol, which is for the wide area networking. We are not using this these days. Instead, we are using something called MPLS, which is layer 2.2 and some part of layer 3 included there. And asynchronous transfer mode, which is another wide area network protocol, which is replaced by things like MPLS, as I mentioned. And you can see the internet layer, which is the network layer protocols, address resolution protocol, as we discussed, ICMP, which is the ping protocol, or trace route or ping using this ICMP for the network troubleshooting and monitoring. And IGMP is the protocol we are using for the layer 2 multicast implemented at the switch layer, including the IGMP snooping functionality. IPv4 at the layer 3, and IPv6 again, which is beyond our scope in this particular course module, but these are the it is having ICMP version 6 and MLD for the multicast and neighbor discovery and all those protocols stack for the IPv6. The transport layer having TCP and UDP, and the upper layers are application layers, application presentation and system layers having HTTP, which is the hypertext transfer protocol, and SMB is the server message block protocol, which is usually for the file sharing and the printer sharing, and the Microsoft and other vendors are quite interested implementing or improving this protocol stack of server message block. Now, the server message block version 3 is there with the several security features. SMTP is a simple mail transfer protocol. So basically for the email servers implementing this for the email receipt and communication. And DNS is the domain name service, which is for the IP address to host address mapping or the URL mapping. RTP is the real-time protocol, usually for the purpose of the streaming or the audio, video, real-time traffic reservation of the paths, and usually this is getting involved with the real-time traffic, real-time transfer protocol. And the SNMP is the network management protocol, simple network management protocol, which is usually to monitor the network. If you have a, let's say, you can configure these on network devices, let's say switch having failure on its fan on the switch. So we can configure SNMP trap to be sent to the central base, so alert or log into the syslog. So SNMP is quite useful in terms of network monitoring. Though these are some of the examples on the TCP/IP protocol stack. And you can see that this is an example of the IEEE 802.11, which is wireless traffic, Wi-Fi traffic usually. The Wi-Fi belongs to 802.11, but Ethernet is 802.3. So you can see there are more fields in here. Data rate included here in terms of the data rate saying that this is 12.12 Mbps, but having the standard of 802.11g. I think now modern day we are having these days Wi-Fi 7 is there. I think it's 802 I can't remember the exact notation. Wi-Fi 1 to Wi-Fi 7 is there now. It's having different IEEE standards with substandard of 802.11. You can see it on the packet capture on the Wi-Fi wireless interface. And the channel frequency mentioned here as well. This is 2.4 gigahertz. Okay, then now we have 5 gigahertz, 6 gigahertz on the latest Wi-Fi 7 and Wi-Fi 6 supporting. The higher bandwidth ones are usually based on the 5 gigahertz or the 6 gigahertz. These are usually for the non-high bandwidth required devices like the cameras and all those things, usually using this 2. The small household devices usually having 2.4 gigahertz because it can go further compared to the 5 gigahertz and 6 gigahertz, but lesser bandwidth. And you can see the RF radio frequency signal and noise level, signal to noise ratios will be measured on the based on the decibels. And you can see all the wireless related the fields in addition to the network layer fields. You see the QoS and the frame check sequence and all those other fields are there. The fragment number, sequence numbers, everything included. But again, we can see the special fields on the wireless with the IEEE 802.11 framing. Somewhat different from the usual Ethernet framing. We discussed this slide previously on the test access port was the span port. I'm not going to explain any further. And the Wireshark capturing, we discussed based on the fields like the previously, you can select the interface, then you can put a capture based on your selection and it will be saved. So you can put a capture with only by putting a capture filter as well. Previously we have captured the you can see that there were when we are starting the capturing process, there is no filter there after we implemented. Now we can filter, implement a capture filter. At the point of starting the capture, you can nominate what's the required filter the capture, only capturing those based on the filtering requirement. In this particular case, you want to capture only the traffic of related to Ethernet, this particular host with a MAC address mentioned here. So you're capturing Ethernet traffic for this host with the particular MAC address. So none of the other traffic will be captured. So you are not wasting resources. You don't need only to troubleshoot this particular host. You know the MAC address. Now we are defining the capture filter by this expression, standardization, and using requesting to capture only this particular Ethernet host or host computer with a network interface card MAC address with this 000815000815. Okay, it is possible to implement the capture filter when you are starting the capturing of interfaces. So by using Wireshark. So that's the capture filters can be done by using this capture filter creation as well by using the GUI. If you are not interested putting the capture filter just by typing it, you can define it by using the GUI itself. It's having Wireshark, the capture filter format, something like this. It's somewhat different from the display filter notifications. This case, you are mentioning the Ethernet address, the filtering string will be only the host address. You can copy and paste as well after your creation. So this is how we are putting capture filters, and these are some of the examples and the syntax you need to follow. The filter, if you are filtering just MAC address, you can put source or destination MAC address um, in terms of capturing requirements. If you need to capture, let's say IP based on the IP address or the host address, you can put this source host and destination host combination, or by using the URLs or the host by DNS. These are then again, you can filter by the port addresses, which is the transport layer TCP or UDP port address, in this case 53 and the port 67. So these are the application port addresses. And you can further by the application protocol like HTTP, TCP, or whatever the protocol. Wise you can filter as well. Let's say you are in the first example, you are planning to capture the host addresses or the MAC based on MAC address. The secondly, you are planning to filter based on the host addresses and the host IP addresses and the host DNS addresses. Then you are planning to capture all the traffic on these port numbers, TCP or UDP port numbers, and filter based on the. Then you are possible to capture by using a protocol name, ARP, ICMP, IP, or whatever it is. Then it is possible to have complex combinations of all these as well. For an example, you can have equal, unequal, greater than, less than, equal or greater than, equal or less than, or not, or double and means ending. It is like you can use complex expressions as well. You don't need to, you just need to capture based on this particular expression is not ARP and port not 53, which is DNS, and not basically this the request is to not to capture any ARP broadcast and not to capture the port address 53, which is DNS, right? So if ARP or DNS traffic need to be avoided, you can put this complex filter based on your requirement. And this particular standard, so syntax standard identified as Berkeley packet filter. This is the standard followed in your capture filters. When you are capturing traffic, starting the capture on your machines, you can define these syntax and filter your traffic on your required scenarios. Rather than capturing entire packet, it will be all the network frames hitting on your network card. Can filter it as well by using these syntaxes or the expressions based on Berkeley packet filter standard or format. Any questions until this point? Okay, that's about capture filter. Capture filters are required when you are capturing on your own device by using Wireshark. But display filters, you don't need to, these are required when you are analyzing packets. You don't need to worry at the time of capturing let's say you got a raw packet with a 2 GB file. So you can't analyze all the packets. So you need something like filtering mechanism. So the captured file captured by somebody else, let's say it can be a tap device, network tap, or the RSPAN, span port, or somebody captured is and shared with you to analyze an issue. So entire 2 GB file you can't analyze. So you need to filter whatever the received packet capture file or PCAP file. Then you need to have filters to analyze specific workflow or the specific issue center. So you can use several criteria to filter, but is that those filters are different from these the Berkeley packet filter standard or syntax. Those filters are something else which is following a different standard or different syntax standard. Display filters can be created in several ways by applying display filters from filter window. So you can apply this on the Wireshark filter in display filter window and define your filters by this by using this display filter window, and by typing the display filter window. If you know how to write the syntax, you can use this the filtering typing at the filtering the display filter bar, which I have shown you previously. This is an example of applying display filter. So it's available on here, number 4. Okay, this display by applying display filters from the conversations or endpoints window, it's possible to apply the display filters from the conversations window, which I have shown you on one of the earlier topics. A to B, B to the communication between two hosts. Once you selected the conversations, you can filter from there as well. You see the display filter window. Now we can apply the syntax on the display and conversations window. And there are by applying save display filters from the filter expression buttons. So we can have your display filters saved, and then from the filter expression button can be recalled for that. Using expressions button for the assistance creating filters, you can create, there's another button which is on top of, we were discussing several buttons on this number 3, I guess. So number 3 having several buttons, you can recall your display filters from there as well. And using right click menus on the specific, if you see the when you are analyzing packets, you can use right click just on the packet number packet, and then you can define the fields there and build a display packet filter from that there onwards for the filtering. You need to remember that display filters use proprietary Wireshark filter format, not like the previously mentioned Berkeley packet filter format, which is protocol dependent and significantly different from fact capture filter syntax. So we are using something different specific to the Wireshark for the syntaxing here. For the display filter. The display filter syntax identified again with the basic protocols. All the protocols the identified when you get a capture opened by Wireshark, that particular precap file, you can see all these fields, or it is categorization by the protocols. In this case, ARP, address resolution protocol, we discussed IP address to MAC address mapping. BootP mainly required for the DHCP. We discussed an activity on the last week, the auto IP assignments, and the DNS, domain name system, DHCP version 6 for the IPv6, and Ethernet, SNMP, Simple Network Management Protocol, SMB, server message block, and the ICMP for the ping, and traceroute, and the RTP, real-time protocol. All these protocols are there. SIP is a session initiation protocol, which is for the usually for the audio traffic or IP telephone implementations require SIP protocol. And display filters are there again with the equal, not equal. All these notifications are possible: greater than, less than, greater than or equal, and the less than or equal. You can see that not ending operations, or XOR, and all those mathematical expressions are there, in the logical expressions are there. The example here, you can see the IP address equal. Equal means you need to type double equal signs. Then IP address, you should mention the IP address as is in case 192.168.1.1.115, and you can put that only to capture this, but it should be, the conversation should not be related to the other IP address. Because you are signing exclamation mark for the not, right? Then the protocol specific, you can the certain protocols having the fields, right? For an example, internet protocol having IP address field, TCP having TCP port address, TCP destination port address, and source port address. The TCP analysis is another way of identifying the traffic related to the controlling of TCP or control plane traffic. UDP port and UDP source port. These are some of the protocol specific fields which is related to the specific protocol. You can use these syntaxes as examples. And then you can use something like IP address ranges by representing 192.168.1.0 means you are capturing 192.1 network address of 192.168.1. range with all the IP addresses there in that particular subnet. So this is these are the possibilities you can do with this display filter syntaxes. You can download all the syntaxes from Wireshark site and get further practice in terms of filtering traffic by using the display filter expressions. So using some of still you can't there can be combinations. I put up a note at bottom. Sometimes some of the combinations are not realistic, and so it will be showing by red if you are typing those combinations, and only possible combinations you can see that green colored once you typed it. All right, so that's about the introduction. So I will be covering the bit of advanced stuff on. So these are some of the reference book. As I mentioned, there are certifications for certain Wireshark examinations. So for an example, Wireshark network analysis is an official, you have an example. So there are the famous writers for these the books, Laura Chappell, and the founder is Gerald Cromes, as we learned initially. And the combination of people, and most of these you can find it on the web. So these are some of the reference book I use for the lecturing in this case. So basically, you can go up to the certification levels for the Wireshark network analyzing. And it's quite fascinating if you're going deep down in terms of troubleshooting. These books can be useful as well. But any questions before we move to the bit of advanced stuff? I will be sending a kind of the lab sheet. So the Dr. Tarandu will be organizing sessions for if I'm not sure what are the sessions he's planning to have, but I will be sending one for Wireshark lab as well. Probably you can do those the exercises with the instructor, and if necessary, they will contact me. Okay, any questions until this we wind up for this introductory session? Okay, let me start the bit of somewhat advanced stuff in terms of the enterprise Wireshark deployments which we require. Okay. Okay, this is the agenda in terms of filter expression buttons and the following TCP, a few different protocol streams, marking and ignoring packets, and the configuring Wireshark. These are some configuration best practices working with packet timestamp. We discussed on the timesync and timestamping and the ER span stuff with the nanosecond timestamping and the colorization, and usually the humans are doing the analysis, right? You prefer having segregation or separation by using coloring rules, and the Wireshark preferences are there. You can put up a profile if you are working for analysis of multiple different businesses or different enterprises as an expert troubleshooting person, then probably you can use profiles for different analysis or different organizations. And the network layer protocols will be a bit discussed in the context. All right, let's start on the filter expression buttons. You can see that filter expression buttons you can create that are based on the display filters. These can be used to quickly apply previously saved display filters. So expression buttons are quite useful in terms of if you are doing, you need to configure your Wireshark based on your own persona, right? The way, so it's quite customizable. So you may, my requirements and your requirements can be drastically different based on your industry where you are, based on your troubleshooting applications or the troubleshooting network behavior and all those. So let's say you are troubleshooting on the low latency requirements, it can be somewhat different. And if you are troubleshooting on the packet drops or the wide area network related stuff, so that's something else. So you need to create your own customizations by using this. You can use one of the tool which is filter expression buttons for quick applying based on your previous experience or previously created display filters. For example, create the filter expression button option that displays only the TCP SYN and SYNAC pin, and you are troubleshooting the TCP operations. So you can create the combinations to analyze TCP session setup parameters, network round trip delays, and session terminations. The session, so these are some of the type following display filter string. You can find it by searching as well. Some of the you can by single search engine or by Wireshark website, you can see these best practices. Others are created as filter expressions. This is an example of type following display filter, starting string into the filter text box to display filter by. So you now by using this particular filter, you are filtering the TCP SYN, SYNAC, FIN, and reset packets with. So this is how you are doing it based on the requirements. So then you just apply, and you are seeing only the TCP the expression filtered packets based on this TCP operational troubleshooting the expressions which you created specifically to troubleshoot TCP. It doesn't show any other protocols, UDP, ARP, whatever the other protocols. So those are noise for your troubleshooting. This is the signal for troubleshooting, which is the filter. Click just by, then after you type on the display filter bar, you just need to apply. Then it will apply to entire packet capture file you are opened, and showing only these. Previously it's showing all the packets. Now after applying the filter, you are only seeing the restricted version of it based on this particular criteria. Then click on the save and give the button name such as TCP. You can give a name as well for later identifications. TCP handshake in this case. So you can see the how to save the filter on this example picture. You are pasting your filter you found out, and you are saving it for the later identification. So it is quite useful in terms of customization. You can see the filter expression button create appear on the right hand side. Once you put the apply, it will apply to all the ones. Once you put save, you can save the filter as well. Okay, then the following you are filtering following TCP, UDP, and SSL stream, secure socket layer streams. Selecting packet in a conversation, right-clicking and selecting follow TCP stream, follow UDP stream can be quite useful in terms of option as appropriate from menu provides display window that contains textual depiction of the payload data from all the packets in a conversation. When you can filter by clicking on the conversation, filter by one of the packets, and right clicking on one of the packets, you have the several criteria to filter it up for the entire stream. So this is possible just by clicking on a packet. When follow stream option is selected, given packet display filters automatically created and applied to support creation of this particular window. The following screenshot illustrate follow TCP stream. So once you press the follow on a TCP packet, it is saying that now you can start seeing the entire stream of traffic. So also note the display filter syntax. Display filter syntax 15 that was created and applied when the stream was selected. So this particular, you can see on the blue color follow TCP stream, it is showing within the bracket TCP dot stream equal 15. So a stream number 15 of the TCP stream filtered for the flow. So I think on the previous slides, the previous plus slides, you may have noticed there is the packet having a row which is included with a stream number. Okay, then let's go to the marking and ignoring packets. Because this is when you are analyzing something, it is important to mark useful traffic for your analysis and unmark or ignore the traffic which may not relevant for your analysis, and it may be noise for your analysis. And it is possible to ignore, or previously ignored traffic can be unignored. So that is possible by using the Wireshark edit menu. So you can see the edit menu having more fields. The mark packet, ignore packet are possible to, that is for the filtering mechanism again in terms of your interested area of concern. For an example, on our previous activity, I explain you how to troubleshoot. First, you are troubleshooting with the implementation engineer, and together, then you find out all the configurations and implementations are fine. Now, you concluded that there is no issue on this particular area of configuration, but now you need to find IP address assignment for the multicast group of different departments. That's our area of concern after that particular point. While you have to analyze, when you start the analysis, initially you need to go through or skim or browse through the overall traffic. But once you understand the issue up to a certain point, or troubleshoot issue up to a certain point, you can omit unrelated ones. That can be done by using this edit menu and mark and ignore packet section there. So that is useful in your day-to-day environments as well, day-to-day stuff as well. Usually, if we concern more on unrelated stuff, when you are focusing on something, then you are unable to focus and find out the exact root cause or issue. So probably omitting the noise is quite important in terms of filtering or the troubleshooting with the Wireshark. So now configuring Wireshark based on several criteria is possible. Wireshark offers a number of features that can be configured to enhance the accuracy and the ease of performing packet analysis activities such as troubleshooting of functional or performance issues. There can be, if you are troubleshooting for the functional issues of your applications or your implementations, that is possible. Even the application have performance issues, then that is even possible to troubleshoot by Wireshark. Not only the network troubleshooting, you can go up to the application level troubleshooting as well by using Wireshark. Selecting the best payment format to measure the elapsed time. So time is quite important in terms of, as we discussed on the time synchronization and time stamping, we will be having several ways to represent the time. We will be discussing that. There are a number of protocol-specific options that affect how Wireshark displays time-related information that are useful. The coloring rules, preferences, and settings profiles can be customized Wireshark for your particular style of analysis, as well as the different environment that you might work on. So it is based on the criteria or the filtering criteria. You can use these tools of Wireshark to make you feel more comfortable. Especially, we need to work, discuss bit on the working with packet timestamps, because just telling timestamp is a generic word, but timestamp may have several references. The colorization rules can be implement to separate different type of traffic if you are investigating different types of traffic based on your criteria. The Wireshark preferences can be implemented for your customization. Usually there are several YouTube videos you can find out their own ways of configuring Wireshark with number of roles. They are usually advising based on the best practices, have been doing Wireshark analysis for many years. So there are several YouTube videos you can find out on their preferences of different people and how they are doing using this Wireshark based on the preference implementations. The Wireshark profiles can be used if you are analyzing traffic for different companies or different sections. Probably there are segments with the low latency, there are segments with the bandwidth intensive, there are segments with the wide area network analysis. So you can create different profiles for the different companies or different area of segments. Okay, let's start on the working with the packet timestamp. So when the packets are captured, Wireshark gives each packet a timestamp. When you capture Wireshark by your own machine, Wireshark giving each packet a timestamp derived from the system clock of your machine. We discussed that each and every machine will be is having a clock. It based on the system clock, it giving a timestamp and showing it us on the packet capture or the capturing mechanism. At that time, in that case, if you are capturing on your own laptop or in computer, the time reference is the time on your own laptop, or the clock on time on your clock of the machine. The timestamp is converted, then timestamp is converted to universal coordinated time, usually named as UTC time, based on the offset calculated from the time zone. Now we are in a time zone with the GMT plus 5:30, right? Based on the time, with the time zone configured on your laptop, usually having those information also gathered while you are capturing and based on your local configuration on the machine. And again, some of the countries which are having seasons, having daylight savings. For an example, the UK having time changes in October, I guess. The 1 hour, they're taking 1 hour forward. So sometimes between the UK time and our time have a difference of 4.5 hours. Sometimes usually it's 5.5, which is they are using GMT in each meantime. So similarly, there can be daylight saving changes. Those are configured on your machines. That is again considered here. So those rules will be applied by Wireshark. Rules that apply for the capture machine and then converted again to another time. That is the reference time. If you haven't synced your machine and just reset all the timing, then the time starting point they consider as epoch number. The UTC based number, then they are and counting a number of seconds from January 1st of 1970. That is a previous convention. So you can find out if your time has not synchronized properly. Sometimes you see this January 1st, 1970. That's because your time, the clock time has resetted, and it does, the machine does not, the clock doesn't have understanding of the current existing time because it does not synchronize with the time source. Then this is the starting time usually. It's the reference in terms of conversion for the Wireshark as well. This is the time convention around the globe. This is the time value that gets saved in the capture for each packet. Then Wireshark reads the capture file and it returns the epoch number back to the familiar date and time based on, it's something like this, right? Let's say you captured on one machine and you are transferring it to another colleague on your office to analyze. So he is not in this your country and he is in somewhere else. So then if you see the time captured, then there can once you open it on this somebody else's machine, so the person you are the receiving, it's showing is based on the criteria of that particular destination machine. So you can play around this, you can get the original time as well. But usually this is how Wireshark behaves in terms of opening. This means that if packet capture is conducted on a machine in Los Angeles, which has an offset of UTC -8, and you look at the same packet capture, same capture file on a machine in Berlin, which is having UTC +1 and overall difference of 9 hours plus DST, daylight saving differences. A packet that was captured on 10 a.m. local time in Los Angeles will display a timestamp 7 p.m. Berlin. So you need to careful on when you are analyzing the time packet captures on this description of the time display on your once you open the PCAP file. Okay, hope it cleared in terms of timestamp. So this is an example of timestamp displays on different time zones are shown possible in the, you can configure capture file time, local offset, displayed time. These are the examples based on the captures of different times and based on the offset. Offset is usually offset is from UTC calculated here. The London or the Greenwich Mean Time is the universal coordinated time. You can see that London offset, if you are in London, then the time, London time does not have an offset. If you are in Los Angeles, you are behind 8 hours. If you are in Berlin, you are ahead of 1 hour. If you are in Bangalore, India, you are ahead of 5:30, which is the same for us. And display time showing based on the exact time where you are in, but captured time is 10 a.m. Its captured time is showing same number for all the sites. The local, based on the local offset, display time has changed when you open the capture on the destination machine or the machine after you copy the capture. Okay, Wireshark display options are there, so you can display the time with the various different formats. These are some of the points. There are wide variety of packet time displays available for use in Wireshark. By default, Wireshark provides time column in the packet list plane configured to display seconds since beginning. So beginning is the time the first packet captured, and cap of the capture with the usually based on the microsecond resolution. You can change it. It's depend on how you captured for each packet with the timestamp resolution or the accuracy of timestamp. Can be millisecond, microsecond based on your capture. However, the way in which time is displayed in the column can be changed by selecting the desired format, time display format option in the view menu. This particular, if you go to the view menu, you can select how you want to see the time. You don't have to stick to by default showing display time. So these are the variations. Even though if you can select the precision as well, you can see in here selected the microseconds. If you have the packet originally captured with the nanosecond timestamp, like in the case of span type 3 we tested, it's if it captured with the nanosecond timestamp, you can put the precision with the nanoseconds. If you haven't captured with the nanosecond timestamp, you can it can be a microsecond. Even if it is not captured on a microsecond or nanosecond timestamp, because due to the lack of facility of the device, then you can click on the microseconds timestamp. For the precision can be selected, and the time format can be selected by using the view menu. So further into the seconds beginning, if the seconds since beginning the capture option, it is in the first packet. That's the first packet, which is the 0 is the timestamp display timestamp there. And then time display menu options provide all these different formats. Let's discuss. The way displayed packet option is illustrated in following screenshot. The captured packet, displayed time packets can be classified, can be different from each other based on your your selection in this particular segment. Okay, let's move to the with details on the how to add a time column. You can add a multiple time columns. You don't have to depend on the display time. You can select any of the ways what we have seen here, and you can see based on the multiple adding another time column based on your preferences. Go to the preferences, edit menu, and the preference icon to open the preference window, then select columns. These are the steps followed to customize adding a new time column based on your the requirement of the combinations shown in the previous thing. And selectable options, you can see that time format even can be different, because Sri Lanka, we are writing with the year first, then month, and then the date. Sometimes US, they are using the format of month first, then date, then the year. So it is based on the selection of various timing options you can use. And there are, for the conversations, you can filter based on the delta time, which is the atomic time for this particular purpose. Delta, this is the elapsed time from the previous packet to the current packet. If you are measuring the time from the previous packet to the next next time in the stream or the series of events, then you can use this delta time field, which I usually add. There are many potential rows you can add based on the different times. The delta time is bit important when if you are analyzing the conversation or the series of conversations between two hosts, or between on a single stream, or different stream between two different hosts. So usually the custom option is there to add these the different columns with the based on your profiles. For an example, in this case, delta time for the conversations is a custom field. You can add to your profile for the customization of your rows and the filtering by using this for the conversations if you are investigating traffic between two hosts or many hosts. Then you can see that the filters there you can use for the filtering purpose. There are several options you can select for your preferences based on the TCP analysis. It is quite important because TCP is a quite the flow quite having the several operations within the flow. So you can use the TCP these expressions on the relative time as well as delta time for the analysis of TCP conversations. So these are you can see that this is an example of how you can configure measure the conversation. Specifically, this is for the TCP conversations. You are putting your selection on the conversation timestamp, track number of bytes in flights, the bytes in flights between two hosts, which is when you are sending traffic. Usually there can be bytes in between on the network, which is on the transit situation, not at the source, not at the receiver, or not at the source or the destination, but it's in the network. You can click all consider selecting all these options when you are analyzing a specific protocol, and its options are there for different protocols. You can see SSL, SSH, and many other protocols are there for the analysis of different times on the conversation of traffic. Okay, that's about timing options, time options for the customization. Then colorization rules. These are quite useful. Colorization of packets displayed in the packet list pane can be effective tool to identify and highlight packets of interest, especially the packets that contain or indicate some kind of error condition. So you can colorize if you are analyzing and packet losses or the packet delays. You can highlight on based on certain colorization. For an example, if certain thresholds are there for some of the packets which is related to make delay or the make packet losses, you can highlight by classifying that. So this is an example of it. In this example, the bad TCP, the TCP issues, TCP IO errors can identified by using this particular the display filter expression. So you can build a color, the bad TCP, and you can put a string there for the selection and make it red, or make it colorized with a red highlight. But likewise, the TCP resets or TTL low unexpected can be defined here. So these, by using expressions and different packet types, can be colorized, and then you can separate and understand, use for your troubleshooting with the separation of different criteria. So for an example, if you want to find out just the bad TCP errors, just copy this particular the filter expression, and it will be filtered with bad TCP or the TCP IO errors. You can even graph that using, there is a IO graph in this particular Wireshark. You can graph all the traffic and then the graph against bad TCP or the TCP errors. You can see the percentage of bad TCP is getting increased or compared to the usual normal traffic. HSRP, we discussed that first of redundant protocol when you're having two routers. So those communications are this. Then spanning tree, we discussed that loop avoidance protocol. This is how you can filter it. OSPF is another dynamic routing protocol. You can identify state changes by implementing these filters and colorize it accordingly. If you are having the ICMP ping or trace route errors, you can put this filter and get colorized by green. And the ARP, address resolution protocol, can be colorized if you want to see only the ARPs highlighted among others. And just ICMP all the traffic. Previously we highlighted by green ICMP errors. All the traffic you can measure, we can highlight from the rest. Then TCP resets, usually the application resets following any TCP resets at the network layer can be identified by these filters and make it red. And again, we discussed on the TTL values, which is getting expired, can be identified. If you need to enhance the TTL value, that can be identified by the putting these filters and on your entire capture. Those are just few examples, and that's about timing previously and the coloring rules. Now we can discuss on the Wireshark preferences. When you are creating different preferences, you can put up a layout. This is selection. These are some of the fields, maybe area of concern. This is used to select the ordering of packet list, packet details, packet bytes, and all those things can be showed in the layout on the top. And the columns, this can be used to add, remove, or move columns in the packet list pane. This is used to set the default capture options. So name resolutions, as we discussed, can be implemented with the DNS or the IP, just not showing the IP addresses. Field type expressions we discuss, and you can create profiles based on these topics or the areas for the different analysis. As an example, in this example, you can use IEEE 802.11, which is the wireless analysis. You can create a different profile for that with the preferences, and the IPv4 only for the validation of checksums. These are some of the use cases you can implement with the preferences of configuring your own Wireshark preferences on different protocols. And you can see these are some of the examples I put up on number of track number of bytes in flights, relative sequence numbers. calculate conversation timestamp. These are quite useful on your day-to-day stuff. It's depend on your use cases. So then the lastly, in terms of preferences, it's your own way of configuring multicast, and it's your way or highway kind of a thing, right? Every person have a kind of a human right or way of their own way of analysis. You need to consider all these options as preferences based on your usual traffic patterns in your enterprises and selections. And then Wireshark profiles. You can create, if you're working for multiple organization, you can create profiles and saving folders and create your own, let's say you're working as a professional packet analyzer and you're getting packet captures from different companies for troubleshooting. Then you can create different profiles for different companies, or the profiling is quite useful in terms of if you are working for multiple projects or multiple networks. So let me discuss bit on the bit of just give me okay, we have 15 roughly 15 minutes. Network layer protocols, we covered the IP and ARP protocols on the previous lecture, the structures and fields in the previous lecture. The basic Wireshark capture and display filters are provided here, and also for the remaining protocols in the following sections. So as we discussed on this particular diagram, having different application layer, transport layer, and the network layer protocols, you can see the capture filter and the display filter comparison. The Wireshark IPv, the Internet Protocol version 4 filters are usually the capture filter. If you need to capture the traffic right now on your machine, you can just put IP as the capture. If you just as the capture filter for the IP traffic only. If you want to put a display filter, we learn the expressions there. In there, you can use capture the IP packets only limited to IP addresses, one IP address, and the source address, IP source address and IP destination address equivalent to the IP ID more than 2000. You can give a complex expressions on the syntax for the the filtering. The capture filters are usually limited, but still you can have more complex ones as well. These are some of the examples you can use. The capturing of ARP and the display filters are more complex options compared to the capture filters. So more rational as well sometimes. So this is another protocol. We discussed only the protocols like the packet captures open for the ARP and IP packets. Now we can consider on IGMP and ICMP as well for analysis. This is an example of IGMP, which were layer 2 multicast protocol we have been using. This is a type of IGMP message. You can see the structure on the layer 3 segment here. Destination, even the Ethernet 2, you can see it identified as IPv4 multicast with the multicast MAC address. You can recall that 01005E. That's a multicast communication. And the protocol, the IPv4, is the field, this same packet having the IPv4 variant, which is the layer 3 protocol, IP version 4, and header length is 24 bytes. But it's mainly a IGMP protocol variant of subset as a IGMP IPv version 4. So now you can see the protocol. The protocol is named as IGMP, and destination MAC address of this thing as the 224.0.0.22. That is the so let me explain bit from the different field type. This is identified as IGMP message, and type 22, or in this case type 2. It's usually a IGMP membership report. If it is type 22, you can see the type membership report within bracket 0 cross 22. So that's IGMP membership report, IGMP version 3, having a separate group, as we learned in the multicast section. It is separate the communication group, usually IGMP version 1 and 2 having 224.0.0.1, 224.0.0.2. Those are the control plane addresses for the IGMP version 1 and 2. But for the IGMP version 3, I discussed that there is a separate group address for the communication, control plane communication, 224.0.0.22. So you can see it here on the destination, and membership report showing that IGMP variant 0/22 means IGMP v3, and is changed to include mode, which indicate that content from the source device is forwarded to the in-group host by multicast router. So you can see that the source having a different the MAC address other than source. Usually it should be unicast, and you can see that multicast address at the bottom 239.255.255.250, which is the multicast group IP address, right? So this particular IGMP packet is for expect the multicast group of 239.255.255. That's the multicast channel. But you are having unique the IGMP v3 having unique IP address for the control plane communication. But the multicast data communication in this particular packet related to 239.255.255.250 group. That's for the data plane, data traffic. That is, you can find on on this particular feed. So likewise, analyzing just packet without having information on the network infrastructure, you can find out these details if you are troubleshooting the multicast network, any multicast network. So usually your area of concern, you are let's say you suddenly got a packet capture from your customer. He does not have network diagram, but he's saying my multicast is not working. So when you ask the questions of what is the IGMP version you are running, he's not answering. Probably my predecessors or my previous engineers was knowing, but I don't know that. The previous those people who implemented multicast now no longer with the company. So you are not getting answers from the customer. So you just need to open the Wireshark capture, the packet capture, and you can find out all the details. What are the IP address ranges, and what is the IGMP version implemented at the client side, and what is the communicated multicast group. All those can be found out with just by opening a packet capture, and you have the data to further analyze. So initially, these are quite useful in terms of your day-to-day work. If you are not getting full network diagrams or the implemented setup there, can find out by just having a packet capture in the relevant area. Okay, so now the previously we discussed on the ARP, IP, and now IGMP completed. Let's go to the oh, before that, another slide is there on the filtering of. We discussed that 01005 is ranging in terms of multicast MAC addresses. The protocol field showing specify IGMP2, which is not representing the IGMP version, but IGMP2 is representing something else. So you need to, if you read it incorrectly, If you identified IGMP version 2 is the protocol by selecting this, it is wrong. It is a different identification with the IGMP. You can see that you need to check once you see the destination address, the 224.0.22, you should have the knowledge to understand this is not IGMP v2, but v3 protocol. Some of the fields are misleading. The IP layer destination IP address belongs to 224.0.2 and which is reserved for the IGMP v3. GMP protocol has multiple versions, and we discuss version 1, 2, and the comparison. Even your assignment seems to be, I think assignment 2 having some of the questions on IGMP. So Wireshark having IGMP filters as well. You can see that just capture filter. If you want to capture the IGMP on your network, it's simple. Just typing IGMP. If you want complex display filter, you can have a IGMP with all these fields just for the capturing with your expressions or the requirements. So it is possible to provide complex display filter as well on your requirements. Okay, now let's go to the ICMP, which is the protocol required for the the troubleshooting by using ping is one of the applications used with the ICMP, and the trace route is another applications. You can see there is description here. ICMP is quite useful in terms of the day-to-day troubleshooting rather than mimicking the application behaviors are possible as well. So ICMP ping, one of the most well-known of ICMP ping, if you are doing just ping, wherein the device send ICMP echo request with a type 8 code that packet distance was. So once you receive the echo reply, then you know that this is working fine. We have the connectivity between source and the destination. And there are situations like you need to measure in the time expired that is required for the trace route application. Round trip time delay can be measured by just ping, number of milliseconds to send from source to the destination, and the receive time. That is the round trip time measured by ICMP pings. But the trace route having different purpose, it is having something called time to live calculations. So time to live is the field on the ICMP overall TCP stack protocols for the layer 4 or transport layer, or or the network layer. So you can, if one layer 3 host passing, then you are decreasing the time to live value. So that way, we discussed this example on the troubleshooting section with the trace route application. So we are just sending first packet with the TTL value 1. Then after the first router meets it, it will send the TTL expiry message back to the source. Likewise, the second packet will be sending with the TTL value 2 expired on the second router. Likewise, you are incrementing up to the destination IP address, and number of hops will be calculated by using the trace route, and the packet losses calculated, identified on each layer based on the response received or not. So you can find out the end-to-end hop by hop reachability to the destination by using trace route application. You can capture those traffic and analyze by using the Wireshark as well. These are some of the explanations on the code numbers you are using for different applications like ping or the trace route. So these are quite useful if you are doing advanced troubleshooting in terms of the code names of ICMP having different characteristics. For an example, 0 code name 0, in this case type 8 code 0, right? Type 0 code 0. These are some of the codes representing certain status. Code 0 and type 0 and code 0, this indicates echo reply packet of ping. So the various packets are there for the same protocol, right? So it is important to identify the code type and the code to understand which packet which ICMP packet you are getting or you are analyzing. So another type we discussed here, type 8 and 0. Can see on this table, type 8 and 0 code is this indicate echo request. Same protocol, but when you are using for different applications, it's having different meanings with the code type and the code name. So another one, there was type 11 and code 0. Type 11 code 0, it is for the TTL expire. When your machine received the ICMP message with the type 11 and 0, it knowing that your TTL has expired, whatever you sent before. All right. So this was the detailed example or this detailed explanation. Time to leave exceed messages based on the type 11 and code 0. You are transferring traffic. Once you receive this packet, you can understand that after the internet protocol layer, first there are frames, then Ethernet layer, then the internet layer, IPv4 internet protocol layer. Then you can see the internet control message protocol, ICMP layer. In there, the message including the type 11 and the code 0. Based on the previous table, this indicates TTL expired in transit. It's not tendered to the destination, the previous packet. So you can find out by expanding further destination IP address. And the time to leave number, which is based on the time to leave expiry, is one you sent previously. And source address, which the trace route sent from this particular IP address. And you are getting a destination address with the multicast. And so basically, that is within the header checksum. You can find out the details how echo ping request sending through the multicast group reserved address. So this is for the communication operate the one of the ways this trace route application works. It's not only the unicast base. There are the validations based on the multicasting rules which are reserved address. So entire protocol trace route application working progress or the operation can be identified this analyzing this packet capture or expanding further on the ICMP protocol. So these are some of the guidelines if you are doing deep dive troubleshooting, but you need to practice these on the practical sessions. Most probably Dr. Tarandi will be arranging later by an instructor. So so these are quite useful in terms of your advanced troubleshooting if you are further investigating. And at least at the management level, you can drill down up to this level and advise your engineers to deep dive based on this knowledge, I guess. So these are the reference books again. Probably you can go through these if you want to master on the network analysis. So that's about the troubleshoot the Wireshark in terms of network analysis. If you have questions, we can discuss now. Okay, probably we can wind up for the day, but just check on your the second assignment, and it's only covered up to the 12th lecture. So you will be having another assignment on the next week. So I will give you sufficient time to submit that as well, because I already given 3 weeks for the second assignment, more than 3 weeks. But this one I will, since we have a sufficient number of weeks before the examination, I can provide you more time on this, the next assignment as well. And I'll be uploading planning to upload another activity. Next week we will be concluding the sessions with the cloud network and fundamentals and cloud network troubleshooting best practices. So that's about it. Any questions? All right, let's find out. Thank you for joining the session. If you have questions, probably you can ask on the next week, or you can send me an email, so anything can be clarified. All right, thanks again.
Thank you, sir.
Thank you. You're welcome.
Thank you.
Thank you, sir.
Okay, you're welcome.